So this is video one of the Kubernetes in the Cloud series, and we're going to look at Amazon's Kubernetes offering, which is Elastic Kubernetes Service. And it complements a couple of videos that we've done before. One, we did AWS autoscaling, and in that we had this Flask microservice that just talked to a simple database, stored some names, got it in and out, and we deployed it with autoscaling on VMs. And that was kind of heavy-handed because these microservices are micro, they're small. And so we did another video, which is we containerized the exact same code and deployed it with AWS App Runner, the simplest container runtime in AWS. But in both cases, we use the same code. It uses the Flask framework and talks to DynamoDB. So this is going to be a fully automated deployment of that same microservices and some web content that we also add with Amazon EKS. And we have all the Terraform and shell scripting to build it and deploy it. And so what we're going to build in this project together is we're going to build an Amazon DynamoDB database. That's what talks to the microservice to store data. Then we're going to build a Docker container that takes that Flask code, builds it with Docker, and so we can use it in EKS. Then we also have 3 additional containers that we're going to build. And these are cool little games that I found, and there's the references here. They're just JavaScript names, Tetris, Frogger, and Breakout. It's essentially pure HTML content. And we're going to package that up in 3 containers. So we end up with 4 containers total. And we're going to push those containers into an Elastic Container Registry. We end up with 2 container registries, one for the flask-app and one for the games. Then after we do that, we're going to deploy EKS. This takes the longest. It takes about 15 to 20 minutes to deploy EKS. And then once that's deployed, we're going to glue up kubectl so that we can deploy some Kubernetes manifests, some YAML essentially, that deploys all of the containers as services and deployments, and then an ingress for them. And then finally, we use NGINX paired with an AWS load balancer, and that gives us, an endpoint. And then we can go to different paths on the endpoints to invoke the games versus the Flask app. So this is, the sort of the abstract layer of EKS. So you've got the control plane. That's the part that we really don't know how they implemented it. Probably EC2s is extracted, fully managed. Now, in our example, we're going to connect kubectl into the control plane. So that's how we're going to interact with the cluster. That's our main interface. And then we end up defining a flask-app node group where we're going to put the flask-app APIs, and then a games node group where we're going to put the games, let's say HTML content. So in our YAML, we'll tag which nodes these should go on by the node selector. And then we have some connected services. The first one is VPC networking. We're running in a VPC. You also were connected to the ECR, Elastic Container Registry. We have to grant permission so the cluster can talk to it. DynamoDB, we have to create a Kubernetes service account or a Kubernetes account that it can interact with the DynamoDB and attach it to these nodes. And that's all done through the YAML along with some Terraform code. Then we have the Elastic Load Balancer. That ends up being a network load balancer in this case. And that is paired with NGINX services to do the path mapping. That, okay, this path goes to the games, this path goes to the API. So that's sort of the abstraction. And again, this looks very consistent across all the cloud providers. Where it gets interesting is, what did it actually go and provision on your behalf? And that's where we get into what we talked about earlier with the platform as a service versus infrastructure. So we got our VPC, we're in US East 2, and for the Flask app, we have an autoscaler group, and it balances between 2 private subnets. Then we have an autoscaling group for game nodes. Now there's only one, it's 111 for desired min max. So there's only one here, but it still manages an autoscaling group. So it's very consistent the way it does that. Then we have the network load balancer that gets provisioned. And it's not a load balancer that's connected to autoscaling or connected to EC2s. It's a load balancer that's done by IPs. And that's because the control plane is going to attach different routes into the Kubernetes cluster, like basically different pods that are running to the network load balancer by IP address. Then outside of our VPC, we've got the DynamoDB table. when we have the two ECR registries, the flask-app, and the games. So now let's talk about the prerequisites before we do the build. Now, there is an AWS and Terraform easy setup that it can walk you through all these steps, but here's basically we're going to need an AWS account. We're going to have to install the AWS CLI, the latest Terraform, then we need Postman, and then we need Docker to build the Docker containers. Okay, so what you want to do is you want to go copy this code right here and go to our development environment and do paste that in. And now we've got the project. So the first thing we want to do, have all those prerequisites installed. So it goes, it checks all the things, it actually logs into AWS CLI for you, and now you're ready to go. So at this point, what you're going to do is run the apply, which is going to run the build. Okay, the build has completed. So now let's bring up the console and take a look at both the Kubernetes cluster that got created and also the infrastructure that we were talking about earlier. And the first thing I'll do is click on EKS, Elastic Kubernetes Service. You can put it up at the top, but click on that, and you will see the flask-app container running 132, which I believe is the latest, and that's good for another year. Then let's click on that. We've got the overview, which and we have to have the right certificate authority. That's all stuff that gets glued up for you when you run the AWS CLI to connect your EKS cluster to kubectl. So you don't need to worry about using this directly. Then we've got this nice resources tab. And this resources tab is essentially a web interface into kubectl. So pods, I'm going to switch to the default namespace, and you'll see the flask-app pods running. And then I can click on to the games, and you'll see Breakout, Frogger, and Tetris. Let's see here, and then the default, the flask-app deployments. There's and then from the cluster, you can see your nodes. Those are the two nodes. And where else was it? The namespaces, which has got default and games, and then all the internal ones like Ingress, NGINX, stuff like that. So that's it for this sort of kubectl interface. Then we've got the compute node, or the compute tab. And in there, you get all the nodes. There's currently 1 or 2 nodes running, and they're T3 medium instance types, and one's in the Flask nodes group and one of the game nodes group. And then the node groups are here. And that'll give you more information on the node groups. So let's go back to the EKS cluster. Then we have the networking, which you can see is attached to your VPC. Okay, that's pretty much it from the EKS cluster there. We got the tags, and we'll look at the other ones. But the other thing is that we build is the ECR, the Elastic Container Registries. And hello, here's my repository. So we got the Flask app and the games, and that's where we're pushing our containers in, and that's where we're pulling them when we're deployed with kubectl. So let's look at the infrastructure, what we were talking about before, infrastructure that gets provisions on your behalf. So let's go to the EC2 element in the console, and let's look at autoscaling groups. And you will see 2 autoscaling groups that get created, each for the different node groups. So we've got Flask node groups and game node groups. It puts a bunch of, unique identifiers in there. Well, if we go in there, you can see that it's just sort of a standard autoscaling group. It's got 1 to 4. There's a launch template, which it manages for you. There's the number of instances, and we've got that. If I go to load balancers, we should have the Kubernetes load balancer that's connected to NGINX. You click on that. So I think I've covered the instances, the load balancers, the auto-scaling groups. I think it's now we're ready to actually test the application endpoints. Validate. Make sure this thing is still running, but more importantly, get this URL. We're going to go to Postman. We're going to put it in here and hit send, and you're going to get the same sort of thing you got in the other exercises. We can also go and do candidates, and you can see there's one, and then I can do a post and send, and then go back to the get and do candidates and the flask-app API. So now let's copy this, and let's go back to the web browser and do a new tab right there, and it's going to say NGINX not found because you didn't use the right path. So now if I go and do games, Tetris, then I could also do Frogger. We have breakout. Those are the four containers. You've got the flask-app, and then you have the games ones, and it's all the routing on the NGINX Ingress that controls which path in the URL gets mounted to which, or which gets routed to which container deployment. So that is the endpoints. Let's do kubectl. Let's do a little kubectl to see if we can get the same views that we've got on the other one. So kubectl get pods. So those are the two flask-app running. Then I can do d namespace to games, and I'll see the games. And I can do kubectl and get nodes, and you'll get the two nodes. And of course, I could describe any of the stuff. So if I describe flask-app Kubernetes situation. And so, yeah, there's things in here. All these projects are the same between the providers other than the image ID. So that is pretty much it. At this point, you could incorporate more YAML, pull, like BusyBox and other examples just to see how the Kubernetes works in EKS. But as usual, you want to be good stewards of your cloud accounts, and these services are not cheap. So there's a destroy thing, and so what we'll do is we'll run the destroy pipeline or the destroy script.